So now that we've learned a little bit about MANOVA and what we can do with it, we're going to talk about a sort of workflow that we can use to really start to drill into the inferences we want to make. And the reason for this is that MANOVA is really testing something pretty complicated. We have multiple groups, we have multiple variables, and we're testing all of them at the same time. We can do pairwise contrast in so many different ways. So we got to figure out what the appropriate way to do all this is. And this is one way that we can think about this. There are other good ways to do it. The book actually describes a different way where you're generating lots of confidence intervals simultaneously. But this is the workflow that David likes, and I like it as well. I think it's pretty intuitive, so let's talk about it. So we've learned two new things so far today, how to run a MANOVA between several groups, and then how to do multivariate pairwise or linear contrast between several groups simultaneously. So we could do pairwise comparisons, or we can do linear contrast between multiple groups. So we can combine these procedures with stuff we already know to sort of develop this workflow. These are also known as protected tests, in that they begin very general and then gradually become more specific. And so there are sort of stopping criteria if the general tests don't turn out to be significant, where you don't probe further. So we start with the full MANOVA that we've already seen. I'm just using the condensed version here of the summary output. You can always get the longer version, the summary capital M MANOVA output. But that doesn't all fit on my slides, but it will give you more detail. It'll give you the B&W matrices, and it'll give you all the different statistics that you might be interested in. But either way, we're going to start here. And if this test is not significant, then I'm going to stop. I'm not going to probe any further. If there's no simultaneous difference between my different groups, P variables, there's no reason to test anything further. If this is significant, then I'm going to move to two pieces in step 2, 2A and 2B. So 2A is what we just saw in the last set of slides. So this is the group contrasts. So my MANOVA was significant. So I want to figure out which, if any, individual groups are significantly different from one another. And it's possible that none of the pairwise comparisons will be significant, and that the difference is driven by some other linear combination of groups. But in this case, we're going to test the individual films against one another. So I'm going to compare Force Awakens to New Hope, Force Awakens to Phantom Menace, and New Hope to Phantom Menace. And so I'll just review the screenshots. We already saw these. This is exactly what we did before, where I'm going to refit the model with a suppressed intercept, and then test my contrasts. So these are just the outputs that we've seen. And we know that each of these is significant. So just as a summary, we know that each of the multivariate pairwise differences were significant. So the differences between Force Awakens and New Hope on all three variables simultaneously was significant. Differences between Force Awakens and Phantom Menace on all three variables is significant. And differences between New Hope and Phantom Menace on all three variables was significant. So step 2B, which I'll do it simultaneously regardless of what I find in step 2A, involves doing univariate ANOVAs. So the group contrasts tell us whether there's simultaneous difference between groups on each of the three variables. But we also want to know, maybe, whether each of our individual variables might differ across all the groups simultaneously. And so this is where we can do univariate ANOVAs. And univariate ANOVAs should be reviewed. But this is sort of an inversion of what we just saw. Whereas before we were doing pairwise comparisons between each group. Now we're doing univariate comparisons of each, or univariate tests of each variable across all three groups. So I'm going to just do a univariate ANOVA with each individual variable as the outcome. So I'm going to do an ANOVA that looks at entertainment across the three groups. Here I find that significant. I'll do one comparing writing across the three groups, or the three films. Again, I find that significant. And then I do one comparing action across the three films. And here we find this is not significant. So people did not significantly differ in their opinions about regarding action across the three films. So just as a summary of my results from step 2B, univariate ANOVA for entertainment was significant across my three groups. F2 equals 98.1.98. P less than 0.01, also significant for writing, but not significant for action. F equals 0.76, P equals 0.47. So for step 3, we're going to combine what we learned in step 2A and step 2B, and we're going to test univariate contrasts. We're only going to do this in cases where the multivariate contrast was significant and in the cases where the univariate ANOVA was significant. So if there was a multivariate contrast between different groups that was not significant, I'm not going to test that pairwise comparison in my univariate ANOVA. Likewise, if there was a univariate ANOVA that was not significant, I'm not going to test the pairwise contrasts for that univariate ANOVA. So those are, again, stopping criteria that will tell us to stop and not probe further in step 3. In cases where both multivariate contrasts are significant and univariate ANOVAs were significant, then we'll go ahead and do univariate contrasts. Let's take a look at what this is going to look like. So in our cases, all 3 multivariate contrasts are significant. So each of the pairwise differences between the 2 films, between each of the 3 possible pairwise contrasts between 2 films was significant. The univariate ANOVAs for entertainment and writing were significant, but the univariate ANOVA for action was not. So given that, we're now going to do univariate pairwise contrasts for entertainment across all 3 groups and for writing across all 3 groups, but not univariate contrasts for action because that was not significant. If there was a pairwise comparison that was also not significant, we would omit that pairwise comparison from our univariate analysis as well. So to do this analysis, we can use the e-means and pairs functions, and the pairs is a very general function that tests all pairwise comparisons. And for this, we can use, these are both from the e-means package. So first we have to create an e-means, an EM object based on our ANOVA, and we specify the grouping variable. So here I just have my ANOVA object for my first univariate ANOVA, which was entertainment. And then if I create my EM object and I call pairs on it, it's going to give me all pairwise contrasts. And so it gives us the 2-key honestly significant difference adjustment by default. But if we wanted to change that, we could use the adjust argument. There's lots of different options. We could do Bonferroni adjustment, or we could do no adjustment. In this case, it doesn't matter. The p-value is so small that adjusting it isn't changing anything. This doesn't change any of the other statistics. It just changes the p-value in this case. It's a slight twist on the way we learn Bonferroni. Instead of adjusting alpha, it does a little algebra and adjusts the p-value instead. And so here is the contrast for our second ANOVA, which is writing. And we're not going to do the third. We're not going to do action because there was no significant difference in the 3 groups for action. So we may just want to do specific contrast and not all pairwise contrast based on what we learned in 2A. So let's say we concluded instead, just hypothetically, there was no difference between A New Hope and Force Awakens in our multivariate pairwise contrast between those 2 groups. So we would then be omitting this comparison from our univariate pairwise contrast, and we'd only be looking at New Hope versus Phantom Menace and Force Awakens versus Phantom Menace, because those were still significant. But New Hope versus Force Awakens was not significant, so we'd be leaving that contrast out. So for this, we could use the contrast singular function, not contrasts, contrast. And this is also in the e-means package. And then we would be listing the contrast we wanted to test as a list in the method equals argument. So here we could list any number of contrasts that we want. So here I'm listing the first contrast, which again, remember our order was Force Awakens, New Hope, Phantom Menace. So this first one is Force Awakens versus Phantom Menace, and the second one is New Hope versus Phantom Menace. And that gives us just the 2 contrasts that we want. And if we go back, you'll see that this is equal to those. So remember, this is Force Awakens, Phantom Menace, and then this is New Hope, Phantom Menace. So Force Awakens, Phantom Menace, New Hope, Phantom Menace, everything's the same. It's the same contrasts. And of course, this doesn't adjust by default. If we want to, we can add the adjust argument and call an adjustment such as Bonferroni or 2-key, and that'll give us the adjustment. Again, it doesn't actually change anything here. The p-value is so small, it's not adjusting. So just as a summary of the work that we did in our conclusions, we started with a one-way MANOVA, and that revealed that there were significant differences in opinions on the entertainment value, writing quality, and action, which are our three variables, between the groups of viewers who saw either New Hope, Phantom Menace, or Force Awakens. So these were our three groups. So these were simultaneous differences on our three variables across our three groups, and there are the statistics that we got that allowed us to conclude it. So after that, we moved on to step 2A, and we found that pairwise multivariate comparisons revealed significant differences between each pairs of movies. And so here we again report each individual pair and the statistical conclusion that we reached. Then we did step 2B. On step 2B, we did univariate ANOVAs. So that revealed significant differences between the three groups on writing quality and entertainment value, but not for action. So therefore, we conclude that there are differences between people's opinions about entertainment value and writing quality for the three films or across the three groups. And then so finally, we get to our most granular conclusion where we test the pairwise univariate comparisons for entertainment and for writing. So here we note that for entertainment value, people preferred A New Hope to Force Awakens by an estimated score of 13.7 on the scale that we were measuring. So the average the average score for New Hope was 13.7 greater than Force Awakens, and there's our pairwise statistical test. They also preferred A New Hope to Phantom Menace by 29.4. So they preferred this was a stronger preference, and so again, there are statistical results. And then the people who saw Force Awakens had a stronger opinion of it than the Phantom Menace as well. And the pattern was similar for writing quality. And once again, there the statistical results are all down there. And so we don't then go forward though and do pairwise comparisons for action because that univariate ANOVA was not significant.